Hello, Latin geometry students. In this assignment, we are going to talk about parallelograms. Parallelogram is a quadrilateral. If you remember this family tree, well, we're going to ignore almost all of this tree and just focus here at parallelograms because the parallelogram has the most rules of any of the different quadrilaterals that we're going to talk about. Now, I say a lot of rules, but if you can remember something from first semester, you can make this really easy. You can remember most of the rules if you can just remember this picture from first semester. Here we have two sets of parallel lines intersecting each other. We had a problem like this on a test at some point in first semester, and I gave you the measure of one angle and then asked you to figure out the measures of all the other angles in the picture. It was actually really easy. Because all these lines were parallel, every angle had one of two measures. The original measure, 110 degrees, or the supplement to it, what we add to 110 to get 180. So in this case, everything turned out to be 110 or 70 degrees because those two add to 180. The shortcut might be noticing that all the wide obtuse angles are 110 degrees and all the acute angles are 70. Well, the same thing applies for this part of the shape that's just in the middle here. This is a parallelogram. And the parallelogram has this angle pattern. If we just ignore all the other stuff here, this part is the parallelogram. And it can help us remember 3 out of the 5 rules we got to know for parallelograms. So a parallelogram, again, is just a quadrilateral, a 4-sided shape, where the opposite sides are parallel to each other. The top's parallel to the bottom, and the left is parallel to the right. And here are the 5 rules for parallelograms. Number 1 is exactly the definition, what we just said. The opposite sides are parallel. And that means when we have a parallelogram, like the one you see up on the screen, these two sides, the top and the bottom, if we extend these lines are parallel to each other. We represent that by drawing in these little arrows. Same thing with the left and the right. The left side and the right side, if we extend these lines are parallel, and we represent that by drawing in these little arrow tick marks. This is a parallelogram. The opposite sides are parallel to each other. The second rule we got to remember is that opposite angles are congruent. This one's actually fairly easy. Here we have a parallelogram. The opposite angles are the ones diagonally across from each other. These two angles are opposite angles, and these two angles are another opposite angle pair. So that means if I tell you that this one angle right here measures 100 degrees, you should easily be able to figure out what this angle measures. It is also 100 degrees. The opposite angles are congruent. And same thing with the other pair. If this angle is 80 degrees, you should be able to figure out easily this angle up here in the upper right is 80 degrees as well. The opposite angles are congruent. The ones diagonal from each other have the same measures. That's rule number 2. Rule number 3 is connected to those angles. It's that the adjacent angles are supplements. Back in this picture, adjacent angles means two angles next to each other. These two angles, they're next to each other. They're not diagonally across from each other. They are supplements. They add to 180. These two angles add to 180. And these two angles add to 180. And these two angles add to 180. And these two angles add to 180. Any two next to each other are going to add to 180. Basically, in the picture, everything is either the same or it's the supplement of a measure. So if you're given the measure of one of these 4 angles, you know all 4 of them. All right. Rule number 4, opposite sides are congruent. Most people associate this with a rectangle, but it actually starts with a parallelogram. The opposite sides are congruent means the top and the bottom, they have to have the same length. So this top segment has to be congruent to the bottom segment. You can't draw a parallelogram if these aren't the same. So these two are congruent. And the same thing with the left side and the right side. The left side and right side here have to be congruent as well. So this is that the opposite sides are congruent. Top and bottom are the same. Left and right are the same. Finally, our 5th rule is the weird one. It's the one that people tend to forget first, is that the diagonals bisect each other. To show this, we're going to switch and use GeoGebra for a second. So the rule we just said about parallelograms says the diagonals bisect each other. Here, I just have 2 segments and a midpoint for each one. See, if I take this segment, I can make it as long or short as I want. This point F is going to stay in the middle. You'll notice that the 2 sides have the same length no matter where I put this thing. Point F is in the middle. It's the midpoint. Same thing for point E in this segment. E is the midpoint. Now, when we say the diagonals of a parallelogram bisect each other, that means if I take these two and give them the same midpoint, what we create here, what we're going to do is then connect these corners, and this will make a parallelogram. This shape ends up being a parallelogram. The diagonals, each of those diagonals is cut in half. Now, you'll notice they're not the same length. We can make one really short. Whoops. We can make one of them really short and one of them really long if we wanted. They do not have to be the same. They just cut each other in half. And if we connect them, we get a parallelogram. So the diagonals in a parallelogram bisect each other. They cut each other in half. They have the same midpoint. And again, it would look something like this. Here's a segment. The blue dot is the midpoint. Since that's the midpoint, this side and this side are the same. Draw another segment and share the midpoint. So that blue point is the midpoint of this new segment. So these two are the same. Then when you connect the dots, we end up, or the endpoints of these segments, we end up creating a parallelogram. But these diagonals are cutting each other in half. They are not the same length. That'll happen in a rectangle. But they do cut each other in half. All right. So those are our 5 rules for parallelograms. Now what we're going to do is take a look at some of the problems that come up for parallelograms. And they range from easy to medium with a little bit of algebra in. But here's the first problem. Here's a parallelogram. It says so right up here, that little symbol. Instead of writing out a parallelogram, we draw a little parallelogram for it. So it says parallelogram ABCD. This is a parallelogram. Find X, Y, and Z. Well, we know one angle in here. We want to find the other 3 angles. It should be pretty easy. First one you want to find is the one that's going to be the same. See, if that angle on the upper left is 65, one of the other angles is also 65. Which one? Well, it should be angle Y, the opposite angle. These 2 angles have to have the same measure. Now, X and Z, whatever one of them is, the other one's going to be as well. They are opposite angles, so they'll be the same. To figure out that measure, it has to be whatever we add to 65 to get 180. So take a moment, find X and Z. To do that, all we got to do is 180 minus 65. And that will give us the measure of both of these, and they both turn out to be 115 degrees. All right, that's an easy version of the problem. Here's the hard version of that problem. Ooh, we threw in some extra X's and whatnot. Okay, when you see a problem like this, it tells us it's a parallelogram right here, so we know something about the angles. Angles are either equal or add to 180. Just like everything else in geometry, angles are equal or they add to 180 and occasionally 90. So in this case, we've got to decide, are these 2 angles supposed to be equal or are they supposed to add to 180? Well, these 2 angles are opposite angles. They're across from each other, so they're going to have the same measure. Since they're the same, we're just going to take the 2, put an equal sign between them, and solve for X. If you do that properly, we get this equation, 2x plus 20 is equal to 3x minus 20, and then just go through the steps of solving for X like any other algebra problem. If you do that right, we're going to end up getting 40 for X. Now, we can take almost the same problem and make it different by simply moving the angle. I'm going to move one of these angles here, and now it's over here. And these 2 angles are no longer across from each other. They're no longer equal to each other. Now they're adjacent. Now these angles have to add to 180 instead. So if they add to 180, we're just going to write this angle plus that angle equals 180 and solve for X. X plus 10 plus 2x plus 20 is equal to 180. We combine our like terms and solve for X. Simply subtract 30 and divide by 3. And in this case, we're going to get X is equal to 50. That's the hard version of those problems. Okay, our problems aren't just about the angles. We also have problems about the sides. Here's the easy version of that. Remember our rule for a parallelogram. Opposite sides are congruent. So very instinctively, you could look at this picture and immediately know what X and Y are, and you'll be correct. X is going to be 7, same as because the opposite sides are congruent. The top is the same as the bottom, and Y is going to be 5. The opposite sides are congruent, so the left and the right have the same measures. The hard version of that problem would simply be throwing in some X plus 3s and whatnot in here. But if we're going to take this problem, we're going to solve for X. We know right off the bat the top is equal to the bottom. So we can write an equation and solve for X. And if we do that right, we're going to get X plus 14 is equal to 3X. And then simply subtract X from both sides and divide by 2. We'll get X is equal to 7. We do the same thing for the Y's. The left side and the right side are congruent. So set them equal to each other and solve for Y. If we do that right, we're going to have 5y minus 4 is equal to 2y plus 8. And subtract 2y from both sides. And then add 4 to both sides. And then divide by 3. And we'll get y is equal to 4. All right, the last kind of problem. This is basically all we really see with the diagonals. And what we have here is this is a parallelogram. I know that because it says parallelogram over here. And we're going to try to find x. Now, these are the measures of the diagonals. You got to remember the rule for diagonals. And the rule for diagonals was the diagonals cut each other in half. In other words, both these diagonals are broken up into equal parts. So this 5x minus 8 has to be equal to 3x. Create that equation and solve for x. If you do that right, we should end up with 5x minus 8 is equal to 3x. And then I subtracted 5x from both sides, divide by -2, and we're going to get, and we're going to get x is equal to 4.